So, as was mentioned at the end of the last video, the first thing that you're going to have to do with any formula before you start to name it is identify it as ionic or covalent. And the giveaway for the ionic compounds is if they start with a metal or ammonium. And so each of these compounds you can see here, this starts with, let me back up. So this compound right here starts with aluminum, that's metal. So we know we're going to use the ionic rules, which mean no prefixes. This starts with sodium, which is a metal. But this one right here starts with ammonium, right, NH4. And that tells us that this is an ionic compound. This, by the way, is the only example. Ammonium-containing compounds are the only example where everything is a nonmetal, but it's still ionic, all right? So once you determine that something is ionic, you know that there's going to be a first name and a last name. And what you need to do is to separate somewhere within these formulas what separates the positive part, the positive ion, from the negative ion. All right. Sometimes that's after the first element. Sometimes it's after the second element. And it's something that you're just going to have to get used to through practice. All right. In this one, it's going to be right here. All right. And we can tell that the positive part of it is the aluminum ions. All right. The negative part of it is the sulfate polyatomic ions. All right. And sulfate is negative because we can see it right here, SO4. All right. That's sulfate. It has a -2 charge. So the name of this guy, its first name is going to be from the thing that's on the left, aluminum, and the second name is going to be from the thing that's on the right, which is sulfate. All right, so we can do the same thing on this compound. All right, between which atoms? Is it going to be between the sodium and the nitrogen? Right here, that separates the positive from the negative, or is it going to be between these elements? All right, and here it's going to be right there. And what you have is you have a sodium monatomic cation, and then you have this thing right here, which if you look at the list, it's going to be nitrate. So this is sodium nitrate. All right, and again, there are no prefixes in these because these are ionic compounds. All right, this one's a little bit tougher to figure out where's that line that separates the positive thing from the negative thing. All right, and so this one right here, it's going to be right there. Okay, so the positive thing is NH4, and that is ammonium, but the negative thing should be everything that's left over here. So what is this thing right here, C2H? That is this polyatomic right here, and that is acetate. So its name is just a matter of stringing those together. This is ammonium acetate. All right, so let's move on to doing some practice with transition metal ionic compounds. All right, so again, with transition metals, this is the case where for transition metals that have multiple ions, all right, where the ion could be one charge or the other, this is going to be where you need to use that Roman numeral to tell you the charge. All right, why is it that in the other compounds, like why is it for magnesium hydroxide, why don't we need the Roman numeral there? Because magnesium is in that second column, and we know that in that particular column, everything has got a +2 charge, all right? But when you get to the transition metals, remember, some of them can have multiple charges. So that Roman numeral tells you what the charge is on that particular compound. All right, so the first one, titanium 3 nitride. All right, so titanium, so we're going to do the same thing that we've done before, where we're going to write down the ions. All right, so what's the charge on titanium? again, it's not, you don't get the charge from its position on the periodic table. It comes from that Roman numeral. All right, nitride. Remember, this is an ide, which means it's going to be a monatomic ion. Nitride is the negative ion of nitrogen, and you can see it's in that -3 column right there. So we can, so we can crisscross these two things, take that down there, put this 3 over here, Ti3 and 3, and you then have a 3-to-3 ratio, which can be simplified to a 1-to-1 TiN. All right, so copper 2 nitride. All right, copper is going to have a +2 charge, and that comes from the Roman numeral. Nitride again is -3. Crisscross these, we get copper Cu3 N2. All right, and a 3-to-2 ratio can't be simplified, so we leave it like that. All right, copper 1 sulfide. The 1 tells you that that's the charge. Sulfide, we know, is a -2 from its position on the periodic table. Crisscross these guys, and we get Cu2S. All right, and I would normally put a 1 there, but I think you're getting used to the idea that you don't put 1s in formulas. So we're just going to go straight to that. In a 2-to-1 ratio, it's fully simplified. We don't need to do anything else. Copper 1 chloride, Cu+. All right, chloride is minus. We crisscross those, CuCl. Okay, so the thing is, these one common mistake that people make is that when they see the Roman numeral, they think that the Roman numeral tells you how many of this you have. All right, and you just have to realize it's the charge, and then you have to still do the crisscross rule to figure out the formula. Okay, so going back the other way. All right, so how are we going to figure out the names from these? Okay, so the first one right here, TiCl4. Let's first of all, we can figure out it's ionic because titanium is a metal and it's in the transition metal region. And so not only do we know it's ionic, but we know we need Roman numerals. It's one of those that's got the multiple charge. Remember, the only transition metals that don't need Roman numerals are silver, cadmium, and zinc. All right, so we know that this guy is going to be titanium, and we know its last name is going to be chloride. All right, but we know it's going to need a Roman numeral, all right, because it's one of those compounds. So again, the way, and if you figure out a quicker way to do this, that's fine. I use the seesaw analogy. All right, so we know that we have 4 chlorides in this compound. So there's 4 of these compounds, of these ions right here. Those add up to a -4 charge. All right, so we know that that -4 charge has got to be balanced by a +4 charge. But what do we get that +4 charge? Well, it can only come from the positive from the cations in the compound. And the only cation is a single titanium atom. So essentially, this titanium has got to pay the whole bill. It's got to come up with that entire +4 charge. So that means that +4 means that this is going to be Roman numeral 4, which is IV. All right. The next one, zinc chloride. All right. I'm throwing this in there on purpose because you might be tempted to look at the periodic table and say, well, zinc is right here. So it's in the transition metal, and so most of the transition metals need Roman numerals. This is that exception. It doesn't need it. We know that zinc has got a +2 charge. All right. So because it does not need that, its name is just plain old zinc chloride. All right. And just be clear about this. Make sure you do not put a Roman numeral in that. All right. This is that one of those 3 exceptions. You know, silver, zinc, and cadmium do not need Roman numerals. All right. The next one, manganese. Let's see. Does that need one? All right. Manganese is right here. So it's in the transition metal region, and you can see that it's not one of those that don't need it. So it's going to be, we know it's going to be, it's going to need a Roman numeral. Manganese. I'm going to save space for a Roman numeral. And then the last name is going to be this right here. So that's going to be phosphide. All right. So doing this, I'm going to do a little bit of a shortcut here and just put these charges. So I know that a phosphide is right here. It's got a -3 charge. So if I have 2 of these, and they each have a -3 charge, that means that is a -6 total charge here. All right, that's got to be balanced by a +6 charge right here. And if that +6 charge can get split by 3 atoms, all right, that means that each of these is only got to come up with a +2 charge. So the ion is going to be +2. All right. So if you think about the ions here, if we've got 2 of these, that's just as much negative charge as you have positive charge over here if we have 3 of this guy right here. All right. So that's going to means that this is going to be manganese 2. So that charge becomes the Roman numeral here. All right. So CuO, that is copper. Leave that blank. Oxide. All right, so oxygen, there's only one of them there, and it's got a -2. So here are the ions that we're dealing with. So right now we don't know what the charge is right here, but here we do. So that's a total of a -2 charge from one of these guys, which has got to be balanced by a +2 charge here, and you only have a single copper atom that's got to come up with that charge. So it has to pay the whole bill. So that means that it's going to be a +2 charge. All right. So that means this is going to be copper 2 oxide. All right. Then one last example, calcium bromide. All right. And when you look at this, and I'm throwing these in there on purpose. All right. Calcium. Okay. First of all, let's figure out, do we need a Roman numeral? Calcium's right here. All right. So this is a compound that does not need a Roman numeral. All right. And the reason you don't need a Roman numeral is there's only one possible charge for a calcium ion, which is +2. All right, so we just call this calcium bromide. All right, it does not need a Roman numeral. All right.